Okay, hi everybody. Welcome back once again to this channel. Thank you very much for joining us once again. If you're new to the channel, guys, please make sure you have subscribed. Just turn on that notification bell so that you can be notified every time when we upload a new session. And this is a new session. It's 2025. It's been quite some time. I think we last engaged in 2024, and now it's 2025. We're going to look at this question, very interesting question under number patterns. Without wasting any time, let's get into it. Okay, so we are given the geometric series, which is m plus m over 1 plus m over 1 plus m squared plus m over 1 plus m exponent 3 to infinity. We are asked to determine the values of m for which the series converges, right? So we know that for a series to converge, our r, which is the common ratio, must be between minus 1 and what? And 1. It means that the first step in this question is for us to determine our common ratio, right? So common ratio is found by saying term number 2 divided by the previous term, which is term number 1. And term number 2 here, it is m over 1 plus m. We are dividing all this by term number 1, which is m, right? So I can write this like this. So if I change the division to multiplication, we know there's over 1. We have to swap there, so it will be 1 over m. M and m cancel. You're left with 1 over 1 plus m. Okay, so it means in this case, it means we need the values of r that are between minus 1 and 1. So obviously we need the values of m, right? So we're going to replace r there with 1 over 1 plus m must be between minus 1 and 1. What are the values now of this m that will ensure that this fraction will always be between minus 1 and 1? Okay, so this expression is quite complicated, right? You might not be able to solve for these values of m just by trying to solve it at once. I know that with a lot of these questions you can solve them, but in this case it's quite different, a bit tricky, interesting at the same time, right? So how do we solve for the values of m? How do we find them? So you break this equation into two, right? So you know that one part of this equation is asking for the values of 1 over m plus 1 that are greater than minus 1, right? Or the values of 1 over m plus 1 that are less than 1, right? That are less than 1. Okay, so we can just separate it like that so that it can be easier for us to be able to solve for each part, because when it's like this, it might be very difficult for us to know what values of m. But when it's like this, it reminds you of grade 11 when you solve inequality equations. Okay, so let's start with this part. The values of 1 over m plus 1 that will always be greater than minus 1. Okay, so the first thing here, we can just take minus 1 and take it to the other side. So we have 1 over m plus 1 because it changes the sign to be positive, and we're left with 0 this side. Okay, lowest common denominator, m plus 1. Then you multiply every term by m plus 1. Here you'll have 1 plus m plus 1, okay, greater than 0. Okay, so this other one, we'll do it at last, the one for less than 1. Let's just keep it somewhere there, and let me continue with this. So we have m plus 2, right? Because 1 plus 1 is 2 over m plus 1 must be greater than what? Must be greater than 0. Okay, we are going to look for those values of m. So to look for those values of m, you can see that in this case, on top, it cannot be 0, right? Because if it's 0, it will make the whole expression to be 0, and 0 greater than 0, it's false, right? Because 0 is equals to 0 in this case. So we know that m must not be equals to negative 2, okay? Because if it's negative 2, it will cause the numerator to be 0, the whole expression to be 0, and to be false, okay? Again, the denominator must not be 0 because our equation will be what? Undefined. So m must not also be equals to -1. So those are our critical values really. So we can treat them as critical values, -2 and what? And -1. Okay, so what we're gonna do is, obviously they cannot be equal to these values, so we're gonna check where this equation or expression is defined. Okay, so we're gonna test with this side where there is 0, 1, like that, 2, right? And obviously this side -3, -4, and see, and also in between where we also have we can have -1.5, something like that. Okay, we check where our equation is valid. Remember how you did it also in grade 11. So I'm gonna check with 1. So I substitute 1 on my m, right? So I want to check on the right hand side of -1, okay, as my critical value. Maybe let me write this critical value in red pen. So it's -2 and -1. So I'm just going to check with 1. So it's going to be, if I check with 1, it's going to be 1 plus 2 over 1 plus 1. Let's check, is this value greater than 0? We are getting 3 on top over 2, and this is 1,5, and indeed 1,5 is greater than 0. It means this side, it's allowing. Okay, so our arrow will face that side. Then let's check with -3, -3 plus 2. I'm getting -1. So I'm saying -3 plus 2 over -3 plus 1. Okay, so that we see if we get an answer that is positive, then I'm getting -1 over -2. Negative and negative, positive 1 over 2 will always be greater than 0. So you saw -3 allowed, right? Obviously with -4 and -4 will always ensure it's negative over negative, which will be positive. So you can see for our expression there, we can see that it's valid when m is less than -2 or m greater than -1. Okay, so our expression becomes valid. Now let's go and check those ones that will be valid for 1 over m plus 1 less than 1. Okay. Okay, let's now check for this one. So we're going to take 1 to this side. So we have 1 over m plus 1 minus 1 must be less than 0. Okay, lowest common denominator m plus 1. We multiply by our lowest common denominator to each term. So here we'll have 1 minus 1 into, then we'll have m plus 1. Okay, less than 0. So we have minus m minus 1 plus 1, which is 0. So it's just minus m over m plus 1 less than 0. Okay, so we have to check our critical values. So obviously in this case, on top it cannot be 0. It means m cannot be 0, right? M cannot be equals to 0. Obviously under the denominator cannot be 0, so m cannot be equals to, so if you equate it to 0, you will realize m cannot be -1, because if it's -1, it's -1 plus 1, which is 0. Okay, so those are our critical values. After getting our critical values, we can go and draw our number line, right? So we go to 0 and -1. Okay, we're just going to check where this equation or expression is valid. So we're going to test on the right hand side of 0 with 1, right? So if you substitute 1 there, so it's -1 over 1 plus 1. So you realize that with 1, it's not allowing because this is going to be negative. Oops, I think I made a mistake somewhere here. So with 1, if we substitute 1 where there is m, we are getting -1 over 2. And -1 over 2 is less than 0. Okay, it's less than 0, so it's allowing. So from this point going there, it's allowing. Okay, let's check with -1. On the left hand side, there's -2 there, so we can check with -2. So it's minus into -2, all divided by negative 2 plus 1. I'm getting negative 2. So negative 2 less than 0, is that correct? Yes, it's correct. So from negative 1 going there like that. So for this equation, we are getting the answers of when m is less than negative 1 or when m is greater than 0. Okay. Okay, so we have solved the values of m for both of our expression, right? When it's less than minus 1, these are the values of m. That must be, m must be less than minus 2, m must be greater than minus 1. But the one that must ensure that 1 over m plus 1 is less than 1, it's when m is less than negative 1 and when m is greater than 0. Okay, so now we need to combine because we need the one in between minus 1 and 1. Okay, so whatever that is valid this side must not affect, must not contradict the other. If it contradicts, we're just going to leave it, right? So let's see. You can see for m less than negative 1, it complement with m less than m less than negative 2. It's sort of complete, or rather what we can do at this point, we can represent all of this in a number line so that we can get the final answer. Okay, so we are going to negative 2, we go to negative 1, we go to 0, we also go to, there's no 1, right? Yeah. Okay, so for 0, for m must be greater than 0. So from this point going there, it is correct. Okay, my number line is gone like this. So from m greater than 0, it's from this point going forward. It's correct, and it's also complemented by m greater than minus 1, right? Although we have to prove that to say greater than minus 1, I'm just going to use a different color, greater than, it's following that one, right? Perhaps let me put it here to say greater than. So obviously we know that m greater than 0, it's correct because it's also complemented by m greater than minus 1, right? Although we just need to prove in between whether that will be the case, right? Maybe we can prove with negative 0.5. We can just go to this equation and substitute negative 0.5 where there is m. So it's 1 over negative 0.5 plus 1. It's giving me 2, right? And you realize that, this is not correct. 2 is not less than 1. Okay, so it means in between here, oops, let me do this. In between here, it's not correct, right? Because you saw negative 0.5 couldn't allow us. So I'm just going to delete this. So far, it's only m greater than 0 that is allowing us, right? Where it is correct. So let's come to yet failed. Let's come to m less than minus 1, right? It's from this point going there. So we're gonna test with negative 1,5 to check at that in between that point. Hence, it was a bit of a tricky question, really. So you can say 1 over negative 1.5 plus 1. I'm getting 2, okay? And 2, it's already outside the interval. So in between there, it's not correct, right? In between won't be correct. So we lastly, so this one is out. This one was fine, greater than, we saw this one was out as well. Now we are left with m less than minus 2. So we can check with minus 2.5 or even minus 3, right? Where there is m, let's go and substitute minus 3 and see what happens. Okay, when I substitute minus 3, I'm getting negative 0.5. Okay, and indeed it's true. Negative 0.5 is between -1 and 1. Maybe let's prove with, let's go and substitute -4 and see what we get. Where there is m, we can substitute -4. I'm getting negative 0.33. So it's also allowing negative 0.33 is between -1 and 1. Maybe let's substitute a bigger number, maybe negative 100. All right. It's giving us negative 0.01, which is still between what? -1 and 1. So you can see from -2 going backward, it's also allowing from -2 going there. Okay, so now we can now find the final answer for which values of m will this series converge. So all values of m, that will ensure that this in between, it's always between -1 and 1. So we have proven it. It's when m is greater than 0, right? Or m less than -2. Okay, this was a bit of a tricky question, but I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.